Alrighty. So I wanted to take a minute to recognize that today is Juneteenth. So I picked kind of at random, aiming towards space and astronomers. As, yeah, astronauts. Three of the many great Black Americans that have contributed to astronomy and space. Arthur Bertram Colbert Walker II is solar physicist, developed X-ray and ultraviolet telescope tech that is still in use today, and I believe it's on several satellites or has been on satellites. Guion Stewart Bluford Jr., aerospace engineer, a USAF fighter pilot, and the first Black American in space aboard Challenger. And Mae Jemison, first Black American woman in space, aboard Endeavour in 1992, an exceptional individual with a degree in chemical engineering and an MD from Cornell. Talk about a rounded person. So I just wanted to make that recognition. Now I'll move on to what I was going to talk about. My agenda, I'm going to talk about the definition, Earth orbiting junk, other solar system junk, yet more junk, impact to astronomy, and what do we do about it? And then summary and credits and stuff. Okay, the definition is any human-made, non-functional object that's in space. Thus includes derelict satellites, discarded rocket stages, lost tools, fragments from collisions and explosions and things, all of that good stuff. And I will tell everybody, I'll just warn you now that this has become something of an obsession of mine. So if I sound like I'm on my soapbox, I kind of am. You can ask my husband, he's been listening to my Morat now for a while.
Especially now with Elon Musk polluting everything.
Yes,
and
and that's in here, by the way.
God, he's terrible.
He's got company. Okay, but the other thing I liked about this subject, by the way, is there's a lot of history involved. I like history. All right. To talk about this, we have to talk about the various Earth orbits. LEO, which is low Earth orbit, MEO, which is medium Earth orbit, duh. GEO, which is further out yet, which is geostationary, so that anything in orbit geostationary stays over the same part of Earth, the equator. HEO, which is highly elliptical orbits, and the Lagrange points, which are not strictly in Earth orbit, but nearby space. And they all are different. They have different challenges, different risks, different history, different sizes, different uses. And we'll also talk about graveyard orbits, but we'll get there yet. So here's a picture of the standard orbits from Earth moving outward. You can see that Leo's obviously low Earth orbit, closest to the Earth. So they go out proportionally. Interestingly, that they have a very different size. Because Leo is close to Earth, it sounds like it's really huge because it's 720 million cubic miles. But considering how much stuff is in there, that's really not so much space. MEO is much huger. It's 38 billion cubic miles. So there's not as severe a problem there. GEO is much smaller because if a satellite goes too far or too close and that's supposed to be in GEO, it won't stay where it belongs over Earth. So it's very narrow. And that only is 5,000 cubic miles, so it's much smaller. LEO obviously has many advantages. It's less expensive to get things in orbit there, lift it into position. You've got a short RTT, which is the round trip time for a signal from Earth to the satellite and back. And the orbit is about 90 minutes. So if there's a blackout because the Earth's on the other side, it doesn't last very long. So there's also HEO orbits, which are much more elliptical. There's some advantages to this. First of all, they're very stable. Also, when the satellite is close to the Earth, it's moving very fast. And that sometimes is good though, because you can get it really close to Earth And at the far end, it's very slow, which allows you more time to do what you're doing. Um, and so that's sometimes very, very useful. It's also used to serve polar regions because the geostationary stuff is only over the equator. So we underserve the poles otherwise. So this is very frequently used. Unfortunately, Leo is the worst of the space junk. There are tens of thousands of items that are being tracked that are in space around Earth. As you can see, this is, I don't know if that's to scale, but it gives you a sense of how much of a cloud of junk there is around it. Those are tracking things that are at least 5 centimeters to 10 centimeters long. Anything smaller than that is not trackable. It's just not visible to us enough that we can really, and there are millions of things up there that are that small. The problem is that these things get worse by interactions. When these things hit together, this junk hits together, it tends to shatter and make more items. So it's a serious problem. By the way, the International Space Station and Hubble both live in Leo. And all spacecraft must transit through Leo to get to space, even if they're not going to stay there. The average life before decay back in Leo varies between decades and beyond. And by the way, beyond includes forever. There are things that are far enough out in Leo that they will never decay and they'll stay out there. So the risk is real. This is back in 2016. You might have heard of this on the news. There was they believe it was a chip of paint that hit the cupola of the International Space Station. Now, of course, it wasn't really a safety concern for this object because there are 4 layers of glass and it only damaged the outer one. But the station is moving at 17,000 miles an hour, so you can imagine the chip of paint quickly becomes a bullet. So they do say that they can actually replace those windows if necessary while they're in space, but it's not easy. I'm not sure anything out there. Field serviceable is easy. So this is wow. These photos got messed up and I hadn't noticed that. I apologize. This is supposed to be show you the cupola, which was added in 2010. And this is the view from outward from the cupola. They have covers that you really can't see because, there's one here. You can see it. Does that show on the screen? The cover here that protects the windows when nobody's actually in there. And those things are very thick and very strong. But the paint chip hit when somebody was actually out there working with it. So, and I understand that the International Space Station has to maneuver about twice a year to avoid known space junk. Doesn't sound like a lot, but still, that's a lot of fuel that we have to spend just to avoid being damaged. So I thought I'd do a comparison. The standard 9mm bullet is 7.5 grams, goes about 820 miles an hour. The average untracked junk is a few grams to a few kilograms and is moving at 17,000 miles an hour. So assuming the same mass, that's about 20 times the momentum of a 9mm bullet. I put this picture of a cannon in here because the 20 times the 9mm is the size of the, this is an M61 autocannon from an aircraft, and it would have the power of that bullet. Now, of course, if it were really shot from this actually has 3 times the muzzle velocity, so that part doesn't compare. But I just wanted to throw that in there so you really have an appreciation of how dangerous that stuff is. So this thing called the Kessler effect was a concept developed by a former NASA astrophysicist, he's retired now, and space debris expert Don Kessler. And it basically is, once we get past a certain critical mass, the amount will keep on increasing. Collisions give rise to more debris and lead to more collisions. Thus, it becomes a chain reaction. And it has the potential to make Leo all but impassable. And that's a picture of Dr. Kessler. And again, it's transferring from, I develop stuff on Apple, and transferring it here to Microsoft sometimes messes me up, and I apologize for that. Okay. So what is being done to alleviate the Leo issue? Not a lot. So currently, basically what we do is we allow things to decay in orbit and burn up in the atmosphere, and that's pretty much what we do, at least for things in Leo. So here's a good example of that. ERS-2, which is an Earth remote sensing ES from the European Space Agency. It was launched in 1995 to replace its predecessor. It was deorbited in 2011, which means it was moved to a lower Leo orbit using whatever remaining fuel it had. So it went from 490 miles out to 360 miles out and allowed the orbit to decay naturally. They try to forecast when it's going to come in and decide where it's going to land. It ultimately broke up safely over the northern Pacific, which was really good. But it's very, very difficult to know exactly where something's going to land. If you looked at a map of the Earth, of the potential places for it to land, it's like at least a third of the Earth. So they can't rule out a lot. But this is a good example. And while the ESA acted responsible according to current standards, it still took 13 years for the orbit to decay and the satellite to break up. And this is like the last image they got of the satellite. You can see that the solar panels are very fluffy. I mean, they're kind of blurred. That's because they're bouncing as it enters the atmosphere. And I said the potential landing path included a large percentage of the surface of the Earth due to the unpredictability. The expectation was that not all of it would burn up, but anything surviving would be very small, which is all very good. One of the things that makes it difficult to predict where something's going to land is because the atmosphere on the Earth actually gets bigger and smaller depending on things like solar activity of all things. So depending on that, obviously depends on when it begins to burn up in the atmosphere. So it's very difficult to predict at this point. So the conclusion is here that even following acting responsibly according to what we say today, it doesn't do enough to alleviate the issue. Not at all. So here's a bad example, and you might have heard about this one in the news at one point too. Cosmos 482 is a bad example because it's a failed Venera issue. It was supposed to go to Venus. It didn't get there. It didn't even leave Earth. It's been stuck in Leo it was stuck in Leo for 53 years. Now this thing was built to survive Venus. Venus is really hot. It has tremendous pressure on its atmosphere, and the chemistry of its atmosphere is really, really nasty stuff. So this thing was built with titanium in order to survive that. Well, that's great, except that when it re-entered the Earth orbit, it stayed in one piece. It survived entry, or at least it's thought to have. It landed in the Indian Ocean, thank goodness, because if it had landed in the middle of the city, it would have been pretty ugly. So this is a bad issue. This shows you how what we're doing today is nowhere near enough. But if you need titanium, you can go find it in the middle of the Indian Ocean. So where did it all come from? Well, 95% of it is the U.S., Russia, and USSR, and China. But France, Japan, India, the ESA, which is, again, European Space Agency, a lot of places have contributed. Most of it's defunct equipment. There are a lot of collisions. I mentioned before, there are tools that are lost in space. And it hugely increases with the use of ASAT weapons. which is anti-satellite weapons. Well, they've been tested, they've been used when we had the US did it once to kill a satellite because it had some kind of fuel on board that they didn't really want to enter the atmosphere. Well, when you blow up a satellite, it creates tens of thousands of items that they have to track. And that's what they track. Remember, they can't track everything because it'd be too small. So, but China did one recently. They blew up it was a weather satellite of their own. It was way out in Leo. It's at the farthest reaches of Leo. And it created tens of thousands of new items, and they are all out there yet. Whereas the one that the US and the Russian one that were killed, those have all burned up in the atmosphere since. But the ASAT weapons, just if any two powers that have ASAT capability ever have a war, Leo will be unusable. And it will be strategic to kill your enemy's satellites. So, MEO, is that any better? Well, not really. It's also getting worse, and distance makes it harder to track. What's in there is broadband internet, GPS, Galileo, GLONASS, and Vido. I'm probably pronouncing that wrong, but those three are respectively our GPS, ESA, Russia, and China's GPS systems. Also, some commercial communications, military, and science satellites are up there. There are only about 250 that are operational right now, which is a fraction of the nearly 15,000 operational satellites in orbit. So obviously, it's not used anywhere near as much as LEO is. There are about 3,700 tracked items. They are spent rockets, fragmented debris, dead aircraft, estimated about hundreds of thousands of tracked debris, slower orbits than in LEO. And this is Telstar, which I think is the first successful. Pardon me. Yes, there it is. Is the first successful MEO satellite, which was 1962. I don't know. The people that are my age probably recognize this picture. Other people, not so much. Okay. But, MEO has 50 times the space that LEO does, and it has less stuff in it. So obviously it's not in as bad a shape at this point. So then what about the GEO stuff? Well, also better than, yes, sir.
Is it evenly distributed, or is it more around the equator?
Well, when you're talking about GEO, it's definitely equatorial. I think there is some concentration equatorial, but from all of when I saw that first image, the cloud, it's really pretty everywhere for LEO. So it depends, I guess, on what we're talking about, which orbits we're talking about. Good question. So GEO has weather, military surveillance, GPS support, which, by the way, makes GPS a lot better than just using the MEO ones. It has communication satellites. There are about 600 operational satellites out there. Slower growth due to stricter controls. They have to, because remember, this is only 5,000 cubic miles of space. This is a very limited space. So they've been very good about this one. They require graveyard orbits, which we'll talk about a little bit more. There are about 500 satellites that are currently in graveyard orbits. A good estimate is unknown as far as how much junk there is there, because it's a lot harder to track. It's way farther out. They do have trouble with zombie satellites. What a zombie is a satellite where they plan to send it into a safer orbit to get it out of the way, a graveyard orbit, but they ran out of fuel before they got it done, and it's still stuck where it was originally. Okay then, so what about HEO, or however you pronounce this one? The helical orbits, generally not much. Now the helical orbits actually go closer to the Earth in LEO and then go farther out. So they're generally not much to risk to the LEO while they're in operation. However, they 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 do go through LEO, and when they're going through LEO, they're going very fast. Because you remember how I was talking, when it's close to the Earth, it goes fast, the perigee. When it's at apogee, the farthest distance, it's much slower. And that's well beyond everything. So these are very inclined orbits, unlike most LEO satellites. They are very actively tracked, so they're trying very hard to make sure that they don't have collisions. But if they did, it would be pretty catastrophic. There are only about 75 operational satellites in HEOs, about 200 defunct, and up to about 2,000 trackable items that are in there that we know about. Generally, the biggest problem here is at end of life of a satellite. They are required to deorbit. Obviously, it usually works, but it has to have already been planned. So anything that's been there for 35 years or whatever probably didn't have an end of life plan. That's been a more recent thing. So interesting, the first successful HEO orbit was a Russian one, on Naya, I guess, one, provided communications to far northern latitudes because they have a lot of far northern latitudes. And in fact, to this day, a particular type of HEO orbit is still known as a Naya orbit because of having set the standard way back when. And that's what the satellite looked like. We also have Lagrange points. These are more like parking spots. As you can see in this diagram, there are multiple ones. They are stable points. They're stable because of the interaction of the gravitational effects of the Earth, the Moon, and mostly the Sun. So L4 and L5 rather, in this picture, upper and bottom, are stable, but they are full of space dust. So if we put something up there, we'd have to deal with that. L3, there's not currently any plan to use. There's really no special purpose to that. L1 is interesting because it always sees the sun. So right now, the SOHO satellite, which is the Solar and Helioscopic Observatory satellite, which has been up there for 30 years and still has years left. They think it still can last to 2029. Is in L1. L2 is where our beloved JWST, the James Webb Space Telescope, that's where that one's sitting. And the JWST, like its predecessors, which was the Herschel and the Planck Space Telescopes, they will eventually be forced out of L2 and go into a heliocentric orbit, so they'll kind of be trailing Earth around the sun when they're decommissioned. Okay, graveyard orbits. These are designated parking zones further from Earth generally than where the LEO, MEO, and GEO orbits are. You use the final thrust burst to force into that alternative orbit to get it away from the active satellites. It's impractical to put enough fuel on board to be able to force it out of orbit entirely. It would require about 150 times more fuel to do that. To entirely deorbit a GEO satellite, push it into graveyard. So that's why that's done. That would cost, it would be extra weight, it would be extra expense to get it into space, lots of bad things, and that's why it's not done. The FCC does require that all telecom satellites commit to an end-of-life graveyard orbit. And there is interagency space coordination committee formed in 1993, which has members from every major player in the game as far as countries. They don't really have authority. However, they have the ear of the UN, and the UN often sets policies based on what they direct. So to Wayne's comment, what about the Tesla in space? It's in an elliptical heliocentric orbit. It's done about 4.5 orbits since its launch in 2018. It has about a 22% chance of end-of-life collision with Earth, or the sun, or the moon. Oh, I'm sorry, or Venus, not the moon. And so that could be ugly. And it actually, although it goes out as far as Mars, it doesn't actually cross Mars' path, so it won't hit Mars. However, I think this is a bad joke gone wrong. I think it's an irresponsible use of precious space, and at least it's not in Leo, at least not now, but a non-zero chance of impacting Earth. And you got to be kidding me. Someday somebody's gonna have to report they had a car accident because a Tesla from space hit. Try telling your insurance company that one.
Linda, I was talking more in terms of he's sending up thousands and thousands of small satellites.
Yeah,
not just that.
I understand, and to be honest, that's just adding to the problem in a big way.
Yeah.
And they'll be trackable, but and again, if these things have a lot of collisions, it's going to create a lot of mess. And it seems the more you put up there, what's the likelihood it's going to go up?
And it should require him, if he sends them up, to track them and control them and be responsible.
And
that would slow them down.
Yes, and since you're a lawyer, I'm going to mention there's not a lot of law to support what the responsibilities and liabilities are with respect to space. So moving on, the moon. There's 103 significant items there. We crashed 15 things into it. We had impactors that were intended for 52 of those. We landed there 33 times. That's not necessarily manned landings. Operational 3 right now, which are all Chinese. Does not include the retroreflectors, experimental equipment, tools, personal articles, U.S. flags, a Bible, golf balls, and etc. that are also on the moon.
That's a heck of a drive to get a golf ball out
there. Yeah. It includes 5 of the third stage Saturn V rockets that were purposely crashed. So all my astronomy friends and members and stuff, anybody know why they were crashed purposely?
Yes.
Yes.
Because they wanted to test moonquakes.
Yes, they had equipment on it to get that data from the moonquakes, and that told them a lot about the interior of the moon. So it was done purposely. Interestingly, they crashed in while we people were on the moon. It was the third stage rockets and some of them landed as close as 50 miles. Now, that's like a rounding error. I would be pretty upset personally if they landed it that close to me. I don't know about anybody else. So, going on a little more about the moon, this is the image of the final stage of Saturn V from Apollo 13. It's north of Mare Cognitum. And this was imaged by the Lunar Reconnaissance Orbiter, which is still out there and still operational to this day. And oh, by the way, they will eventually take the Lunar Reconnaissance Orbiter and crash that into the moon, and they're going to be very careful to avoid hitting the historic sites like where Apollo 11 landed and things like that. But it's still going to crash. And Chang'e missions, these are the Chinese ones. These are the only ones that are still active. And they've already had several missions, and they've left behind all kinds of stuff too, landers, rovers, and various scientific equipment. So not only the side of the moon that we can see has stuff on it, the Chinese have left it on the far side of the moon too. Not the dark side, the far side. Well, let's talk about the planets now. Mercury, Messenger, was a great satellite, gave us a whole lot of information and mapping of the surface of the planet. It was crashed in the northern hemisphere intentionally. It was we believe it's completely destroyed, and it was about a 52 foot wide crater, but that's all estimated. We don't have any images of it yet. Mariner 10 was also mapping Mercury, but it did not crash it. It is now in a permanent heliocentric orbit following it. It periodically crosses the Mercury's orbital plane, but is not expected to crash into it. Soon there'll be a Bepi Colombo, which is an ESA, and JAXA, which is Japan space. Likely, ultimately, will be crashed into Mercury as well. Venus. The good news, nothing survives in Venus. Regardless, there were about 24 mission remnants, totaling about 15 tons of absolute junk, probably barely recognizable now because, again, we're talking about a very caustic atmosphere, tons and tons of pressure, more pressure than the deepest part of our oceans, and just very hot, like 900 degrees hot. Only the JAXA craft, which is defunct, still orbits Venus. I'm not even going to attempt to say that. That's Suki. The Soviet lander Venera 13 survived only 127 minutes, but that actually exceeds the expected life by 4 times, by more than 4 times. It did successfully send images back to Earth. I think, well, I'm going to say it now. I think it's super impressive that the USSR was so successful with this mission. I mean, not that Venus is the most fascinating place, because the likelihood of life is like really, really extraordinarily unlikely. And it's not exactly beautiful, but to make something that survived that nasty atmosphere 4 times more than they designed life was pretty impressive. Maybe one of the most important things, most amazing things that the USS ever did in space. Okay, Mars. We've had 14 missions, some with multiple spacecraft. We have about 8 tons of active and crashed spacecraft and other hardware. Began in 1971 with USSR's Mars 2 mission. The most recent one was Mars in 2020 with Perseverance and Ingenuity. And there's still a project. That mission has all of these little titanium sample things that are on the surface of the Mars, and they're still working to figure out how to get them back to Earth. The initial return mission was defunded by Congress, but the engineering for a future such mission continues. But interestingly, you've probably heard of all these things. Spirit became junk in 2010, Opportunity became junk in 2018, and Ingenuity, which is the picture here, the little helicopter thing, became junk in 2024. Perseverance is well named, it's still functioning, and is expected to function until about 2031. Things are a little unpredictable on Mars. There are also 11 orbiters, 6 of which are still active, 2 years, and then you can see the countries there. I was surprised that the United Arab Emirates, thank you, also has one there. We don't know the fates of many of these defunct orbiters because we haven't seen them in mappings, and we don't think the atmosphere is dense enough to totally burn them up. Plus, missions to Mars have a high failure rate. Admittedly, most of that was early in the space program years, but about 60% failure rate. So there's all kinds of stuff. Phobos was supposed to have debris on it, but they missed. They weren't able to get it there. And no mission has ever considered landing on the other moon, which is Deimos. So, example, Mariner 9, which is one of NASA's, they really don't know what the fate of it was. Yeah, I'm sure someday we'll figure it out. Jupiter and its moons. Missions already ended. Ulysses is now permanently in a heliocentric orbit. Galileo ended its life by plunging into Jupiter. There are missions in process. Juno, which will also dive eventually into Jupiter, it's a mapping mission. JUICE, which is from the ESA, will ultimately crash into Ganymede. And the Europa Clipper, which I'm sure a lot of people like me are very excited about, was originally planned to deorbit into Jupiter, but to save money, it will crash into Ganymede. And what they've planned to do is do a scraping landing. So it'll come in at an extreme angle and scrape itself to a stop. They don't want to smash the ice, smash it into the ice, which could cause a significant pollution to something that could hold life. Personally, in my humble opinion, that's a financial decision, not a scientific one. So, and by the way, Jupiter is also visited by other things, but they were flyby missions, and I'll be talking about them in a minute or two. Some pictures, you can see the Europa Clipper up in the left, and the bottom is JUICE, and there's Juno. And you can see how important, when you get as far out as Jupiter, you need huge amounts of solar cells. So they all have these massively different sets of cells. But I'm very excited about what JUICE and the Europa Clipper missions are going to be doing, because we're looking for the possibility of understanding Europa and Ganymede better, and someday planning to find ways to test to see if it actually has life on board. Fingers crossed.
Shoemaker Levy 9 was really interested.
Yes.
Crashed into Jupiter.
Yeah.
And left, even though they were very small, left that huge scar
Yeah.
on Jupiter, which eventually went away, but that was cool.
Yeah. I saw that out of several telescopes, including the ones here. So it was really cool.
Yeah, it was easy to see.
It was easy to see. Yep. And I don't know if when they crashed the other one, the first ones there, Ulysses, no, I'm sorry, Galileo is the one that was plunged into Jupiter. I wonder if they were able to see where that happened. I never heard, so I should look that up. Moving on. Saturn, Uranus, Neptune, and Pluto. No active satellites currently. Only Saturn ever had its own orbiter, which was Cassini. It's actually Cassini-Huygens, but I know that's not how that vowel was supposed to sound in Dutch, and I can't possibly contort my mouth enough to get it right. Cassini was deliberately crashed into Saturn's atmosphere to keep it from colliding with Titan or Enceladus, which are all two other candidates for potential life. But Saturn is a puffy planet, so crashed is kind of a funny word. It's probably not the right word. So it turns out that it survived for 91 seconds as it plunged into the atmosphere, which was more than was expected. They expected only about 30 seconds. And at 90 seconds, it didn't destroy the aircraft yet. What happened is it forced the communications to no longer be pointed at Earth, so we lost communication first. And it was eventually crushed, I'm sure. And oh, by the way, for members that really are opinionated about it, I have carefully and diplomatically avoided the issue of whether Pluto is classified as a planet or not. And there was supposed to be a picture there. I'm going to have to go back and fix this. But that was a picture of Huygens, the Cassini-Huygens. All right. Other solar system bodies. We have the near Shoemaker lady, near Shoemaker, sorry, because we just talked about the other thing. Softly landed and stays on Eros in 2001. Ceres, the Dawn satellite, is in a stable orbit around it. Comet 67P, I'm not even going to attempt to say those names. Rosetta lander had a lander called Philae, and the main Rosetta craft itself are now derelict on that comet. So it's actually marked on a comet. Osiris Rex didn't actually leave any physical stuff on Bennu, but it did damage the surface. It made a big dent when it landed, and because it scraped up samples and stuff, so it made some mess of there. It's been renamed Osiris Apex and is now en route to another asteroid. And afterwards, it will likely crash into that asteroid when it's done with its life. That asteroid is going to make a very close approach to the Earth in 2029, and we believe that ESA is also going to send up a probe to that, but the ultimate demise of that has not yet been planned. But it'll be really interesting to see. There was a time they thought this might actually impact the Earth, but they determined that it won't. And here's what the Rosetta mission, that's the comet that kind of looks like a rubber duck. And there's a picture, it shows the picture of both the satellite and its lander. I happen to like rubber ducks, so I like that comet. Okay, junk beyond the solar system. Ooh, please don't be mad at me for calling it junk. Pioneer 10, which was launched in 1972. Last contact was in 2003. I can't talk today. It's about 138 astronomical units, which is the 93 million miles between us and the sun. It's about 138 of those out. Pioneer 11 was launched in 1973. Last contact was farther ago, 1995. It's not quite as far out, but it's still going fast. Voyager 1, which was launched in 1977, it's still active, and that's the farthest out at 173 astronomical units and very fast moving. Voyager 2 was launched the same year, is still active also, not quite as far out. And then the New Horizons, which was launched in 2006, is still active, and it's about 52 AU out. So I'm glad that the people that handle these missions aren't here. They might object to me calling them space junk, but they're going to be at some point in the future. Of course, the pioneers already are. Fortunately, none of this stuff is in a collision course for anything that we know about, and certainly no time soon. They have millions and millions and millions and millions and millions of miles. The New Horizons, by the way, will eventually overtake the Pioneers, but it will never overtake the Voyagers. The Voyagers are moving that much faster. Okay. And here's images of those already space junk. That's a picture of Pioneer, both 10 and 11. They were nearly identical, not entirely identical. There was actually a very, very interesting piece of equipment that was included on Pioneer 11 that wasn't on Pioneer 10, and its purpose was to detect the magnetosphere around the planets. The one in the middle, that is basically, it's the Voyager. They were identical. Voyager 1 and 2 were pretty much identical. And then this is the New Horizons. That gave us all those wonderful images of Pluto. So why do astronomers care? Well, in addition to all the previous reasons, we're concerned with the health of Hubble and other space telescopes because Hubble is in Leo. We're worried about the ability to launch space exploration satellites, of course, because we love seeing all that stuff. We don't like adding a human-made risk to our species' exploration of space. And it also makes a mess of our astrophotos. How many people have taken astrophotos and had all kinds of, yeah, I see somebody waving in the back. Yeah, they make a mess. But you'll notice in the next slide that we're part of the problem too. These are the space telescopes, how many have been launched and how many are still active. Now, this number is a little bit inflated because some of these are on the same platform. So for example, there are multiple pieces of this that are on Hubble. So it kind of overstates it. It's not, these are not individual launches. I didn't go that way. But there are currently 16 more planned. And oh, by the way, the very first successful space telescope, which was in 1968, the OAO, which is the Orbiting Astronomical Observatory, was the first one launched into LEO. It's still there. And NASA is trying to bring it back for historical reasons. They're trying to figure out a way to bring it back, which I think would be really interesting. And also, in doing so, they're possibly coming up with a way that we can start to get some of the mess out of LEO. So the question is it really as bad as it sounds? Well, with respect to LEO, yes. At this time, the only graveyard orbits and deorbiting are options, and the graveyard orbits are more problematic with LEO because there's not a lot of room for that. By the way, even if we added nothing new to LEO starting right now, LEO would never completely clear itself. Not everything's in an orbit that will eventually decay. So the debris generation in LEO already outpaces the natural atmospheric decay. So we are on the eve of that Kessler syndrome if we're not already in it. Depending on what scientists you talk to and how they define things, it's already a problem. So what can be done about it? Well, nothing right now. However, there are all kinds of technologies that are under development. So the Swiss company ClearSpace has been chosen by ESA to develop, robotic claws and arms and things. Now, one of the problems here, of course, these things are moving at 17,000 miles an hour. So you have to find it, catch it safely at 17,000 miles an hour, and find a way to bring it back to the and push it into the atmosphere or do something to cause it to go away. Now, the Japanese Astroscale is building spacecraft with powerful magnets, and this will help bring down satellites, but only satellites that have been built for that possibility. So we're years away from that having any impact. There are other discussions of having harpoons and nets. The UK's working on something. They've done some tests, just to make sure it's potential, but nothing's available yet. And they're also talking about built-in self-destruct mechanisms to force deorbiting, as long as that's what it does, as opposed to explode the spacecraft, which would only make it worse. So, this is obviously something that we need to, as a species, address and figure out how to take care of this. And the U.S., by the way, is kind of, other than the fact that they're trying to pull down the OAO space telescope that they put up back in 1968, the U.S. really isn't doing as much on this as ESA, and ESA is definitely in the lead on this, and like Japan and other places are working on it. We're not really doing as much. So that's one of the reasons this has become a soapbox item for me, because I'm just like, this has got to stop. We've got to do something here. So, well, in summary, since the first V2 rocket was launched in 1944 and Sputnik first orbited the Earth in 1957, we blasted a tremendous amount of satellites and stuff into space. There was no consideration given to end of life at the time because space is big. But we're now at the threshold of a runaway chain reaction that could make it very difficult and dangerous to put anything more into orbit. The problem won't ever fix itself. So we need international efforts to address the issue, and they have to be funded and they have to be moved forward. And as I mentioned before, we have legal issues to deal with as well. So it's not an easy thing. So thanks to more websites than I can possibly list here for all the information. I use Safari's AI. By the way, you have to be careful, because I found out if I asked a question, it answered my question, but if I didn't ask the question right, it didn't give me the right information. So when you use AI, be careful. To Mary Duca for the opportunity to speak, to my family, my husband, and friends for putting up with my sudden harangues on the subject, my dogs for fewer fetch games while I was working on this, Bonnie and Al Wiskell for their continued support, and all of you for being a great audience.